Welcome to Study Loop.
So in this question, we have a layer of soap film that is n equals 1.34 on top of glass that is n point 1.52. So we're asked about how thick is a film if it reflects the red light more strongly when illuminated normally by white light. So that means it experiences constructive interference for red light. And if we write down the n, and we remember that a phase shift of pi will occur every time light is reflected at the boundary of when it encounters a media of higher refractive index, then we know that it will experience phase shift at both of these boundaries, and that will cancel each other. So in order to have constructive interference, we have 2t equals m times lambda. And lambda n because it's lambda inside the media instead of lambda in the air. So this question, m could be any value, but since this question does not specify which m it wants, I'm gonna assume it's the lowest m. So that is to say, we want the thinnest, the smallest thickness of the film, because you can have m equals 2, m equals 3, m equals infinity. All of these are going to work, but I'm just going to find the smallest m. So usually when we try to find the smallest value of m, we start from 0 and we go 0, 1, 2, 3, etc. But 0 does not work in this case. Why? Because if it is 0, that means there is barely any coating, and in that case, the coating will reflect any light equally, because for t equals 0 and m equals 0, lambda could be anything. So if you have a white light incident onto a 0 thickness coating, what will happen is that all the white light will be reflected. But right now what you have is you have white light incident onto the coating, but only the red light is most strongly reflected. So that means it cannot be 0, otherwise other wavelengths will be equally strongly reflected. So we start with m equals 1. So in this case, we have t equals m lambda n over 2 equals lambda over 2 times n equals 643 nanometer, 2 times 1.34. So that gives us 240 nanometer. So that is the thickness of the coating. And you can find the thickness by assuming m equals 2 and 3. So t really could be any integer numbers of 240 nanometer. It could also be 480 nanometer. It could also be 720 nanometer, etc. But this is a minimum thickness required for this coating. And this is actually, it's also a more realistic thickness for the soap film, because we know the soap coating cannot be infinitely thick.